We start with a question. Can we compile a BBS from source code using modern development tools? Today on the Serial Port, we're going back to the BBS world to hopefully bring one into the modern era. We're taking a look at Impulse, a BBS platform popular with underground boards in the 90s. We'll talk to the original author of Impulse, Brandon Sneed.
If you wanted to do something back then, there was nothing to stop you.
And we'll see if we can bring this 90s relic back into action with a modern twist. But why BBSes in the first place? So one of the things we've struggled with is conveying exactly what it was like to use a BBS. And if you were around in that era, you probably know what we mean. Both Mark and I caught the tail end of the BBS scene. We first connected to them in the mid-90s, and we were never really old enough to become as involved with it as we wanted to be. And by the time we were, BBSs were mostly long gone. So for us, learning more about this era gives us a glimpse into a world that we kind of desperately wanted to know more about at the time. Except the difference now is we can actually do something with it. To that end, we've decided to try to do something we never had the knowledge to do back then. Build a BBS from source code and actually get it running. And while we're most familiar with BBSs like Teleguard and Renegade, we're taking a look at another less well-known BBS called Impulse. Impulse was most popular with what were called scene BBSs, mainly underground invitation-only boards that featured everything from wares, hacking, music, demos, and especially art. ANSI and ASCII art, so called for the different character sets they represent, quickly became a popular method of customizing a BBS. What started out as simplistic illustrations soon evolved into an entire genre of art, bringing the styles of street art, abstract, comic, and everything in between onto a completely new digital medium. Artists took these colored blocks and characters to incredible heights, creating multi-page masterpieces that defied belief. And in the early 80s, a teenager in Mesquite, Texas, a suburb of Dallas, had no idea this pixelated paradise awaited him.
Dallas didn't have except for it being hot, you know. That was the only claim to fame.
That's Brandon Sneed. He would later go on to create Impulse, but his introduction to BBSs took a more traditional route.
It was really through my dad. He was an auto mechanic. He liked playing video games and stuff, but he was very dissatisfied with, you know, like how awesome or terrible, you know, Ataris were at the time, and even like the little Nintendo 16. So he ends up buying a computer, and then so he started doing the BBS stuff, and it was like what I would have classified as like old man stuff, where they go on a BBS and they start talking about tools or like, you know, boats and you know, stuff like that.
For most teenagers during this era, it was difficult to even get glimpses of the scene, as many scene BBSs originated in big cities like New York City. The concept of being charged for a long-distance call is completely foreign to us today. But back in the 80s and 90s, it could be downright expensive to make a call outside of your local area code. This meant that, especially for a teenager, you were really just limited to calling the boards in your local area.
The stuff that was local those were the places my dad was calling, you know what I mean? And so like those are the ones where it's very basic. It's like you get on there, maybe you play a door game or something. You do the multi-user chat, or, you know, post messages on their message boards. I don't know. There wasn't anything that's exciting about that. It was all the art boards and stuff that were exciting, because not only, you know, were you seeing ANSI art and stuff like that, like stuff from the demo scene was leaking onto those boards. And so like you would get these amazing little 32K programs that were like hour long, like visual craziness, you know, and that was way more entertaining to me than having arguments about, you know, like if snap-on wrenches are the best, or, you know, like whatever stuff that he was into.
At the dawn of the scene, the boards catering to it were few and far between. But for enterprising youth, that was just a minor inconvenience.
If you ever saw like the old 2600 magazines or anything like that, they covered a lot of this hacking stuff. But basically, you would dial this PBX number, which you would probably get from somebody that you knew, who was probably a little bit older than you and had access to like a workplace where they have one of these things active. And you would call it, and you would enter a 6-digit code at random. And if you got a busy signal, you knew that the code wasn't valid. But if you entered that 6-digit code and then you got a dial tone, then you could enter another number after that and then dial out to a BBS. So you'd leave this thing running overnight, and it'd probably pick up, I don't know, 4 or 5 of these 6-digit codes over time.
This practice, known as war dialing, was a popular way for hackers and freaks, with a PH, basically phone hackers, to find systems that could be compromised. It was equivalent to doing an in-map scan today of IP networks. A modem would dial entire blocks of phone numbers, noting which ones would result in a dial tone, allowing a caller to make a relatively anonymous call to a long-distance number for free.
And then you would write all those codes down, and then you would use those until they stopped working. And then you would move on to the next one and use that until it stopped working, and so on and so forth. So then you're making all these calls to like the 915 area code. I can't even remember the name of some of these BBSs, but there were several of them, really, really popular big ones in New York, at least as it related to like the ANSI art scene.
And along with ANSI and ASCII art, the other subcultures like wares, music, demos, and so on would often overlap.
It was a door to all these different things. You know, it started out as BBSs, but then it went into art and then programming and then, you know, the hacking and all that kind of stuff. And then after doing all that stuff for, I don't know, 4 or 5 years is when I started actually learning how to program. And you know, like there's no, and I will tell everybody to this day, because I've been a software engineer for 30 something years now, the best way to learn how to write software, whatever, is have something that you're interested in. And so BBSs was something that I was interested in, and so I wanted to run my own, and that turned into writing my own because I wasn't happy with the stuff that I was seeing. And yes, that's kind of it, I guess.
In the late 80s, Sneed began coding a new BBS based off of Forum PC, a popular BBS platform to expand on. It was written in Pascal, and Sneed began learning the language to craft his own BBS. But his development platform at the time was pretty limited.
My computer was like probably the crappiest computer you get. Like whenever I got it, it was already outdated. Like my dad was rolling a 386 over there like a boss, and I've got like this 8088, you know.
In the early 90s, the art scene became more organized. Groups like Acid, Ice, and others began forming, composed of like-minded members that would create artistic works either for themselves or even for paying customers that would then be released in packs, typically every month. Sneed was initially part of several art groups like Unison, Relic, and CIA, among others, releasing art in the early to mid-90s under the handle Nivenh H. And despite having success and moving up in the art scene, his burgeoning passion and interest for programming began to take hold.
And like when I got in there, you know, like I spent all this time, you know, drawing this art, meeting these people, doing all the schmoozing that is, you know, you would have to do to get into like one of those cliques or whatever. Only to about the time I got into it, and I wasn't too hyped about it. Not because they weren't doing great stuff, because they were, but my personal interest had already started to move over to the software development side by that time.
By this point, his BBS software was coined Impulse and was now based off of Teleguard. Having dedicated himself to coding, Sneed joined the two most prominent scene groups, ICE and then later Acid Productions. But even with his connections in the scene, developers in this era had to be much more self-sufficient. Just think of the innumerable resources that developers have today, from a vibrant and massive open source community, GitHub, Stack Overflow, and now, for better or worse, AI. Back in the 90s, though, sharing code wasn't anywhere near as common.
That was the norm in the software industry. Everything was like this closely guarded secret. There was no open source. Everything was shareware. There wasn't easy ways to get a hold of stuff like those Dr. Dobbs CDs. Like you had to subscribe to whatever their magazine was or whatever in order to get those CDs. But then that just gave you the opportunity to be able to purchase those CDs. You're a kid, you don't have money to do that kind of stuff. You barely get, $5 out of your mom to, go hang out with the homies for the day and maybe be able to get a drink or two so you don't sweat to death.
Sneed kept developing Impulse through 1996, with version 6 pre-release 5 being the last public release under his name. Around that time, as more of the BBS scene moved over to the internet and started hanging out on IRC, Sneed began pivoting Impulse to have more of an internet focus, rebranding the project as Nexus 2 and planning for Telnet support. While he ultimately didn't carry Nexus 2 through to an official release, the original Impulse code didn't disappear. It eventually ended up in the hands of another scene member named Horrid, who released version 7.1 in 1998, the final official release of Impulse. But his experience with Impulse and BBSes as a whole changed his life.
I look back on that, and it was like one of my best times in computing. Like we've seen the internet come around, we got this AI stuff coming up now. That's still my favorite, because like if you wanted to do something back then, there was nothing to stop you. There's no drivers, there's no like security issues in the way, there's like nothing. It's like, oh, you want to initialize this piece of hardware, hit int16, supply this value, and now it's up and running, and now you can do whatever it is that you want with it. It was just like, it was very raw. The irony of that little selfish act of, me trying to be a cool guy and stuff ended up launching my career effectively. And it's been amazing for me. It was just a blast to do it. Not just because I was learning so much, but I was also interacting with people who were a lot older and more mature than me. So I was learning that way too. But then it was just so much fun, right? Like the art and the music and all the demo stuff and just creative exploration like happening in abundance everywhere. Like I would never, the BBS thing, yes, that was fun, but that was the best part of it for me, was like all that stuff happening, and that just happened to be, that was a vehicle for me to be able to participate in that world. And I'll never forget it at all. I was hyped that you guys got in touch with me, because I'm like, this is crazy. I would have never.
Inspired by the story of Impulse, we decided to bring it back. But there was just one small problem. We don't have much programming experience, and I guess it's been decades since either of us have even looked at Pascal source code. And so this is kind of turning into more than just a restoration project, because we're going to have to relearn the basics and figure out how to work with the Impulse source code using modern development tools while still keeping it compatible with old hardware. Speaking of which, we've chosen a PC that should be a perfect testbed for our BBS. This computer from 1996 was built by Microgram, and it has an AMD K5 100MHz CPU, 32 megabytes of RAM, and we've outfitted it with an SD to IDE adapter, a PCI NIC, and a dial-up modem. We've loaded MS-DOS 6.22 along with MS LAN Manager to allow us to connect a network drive so we can rapidly test new BBS builds. Fortunately, old clients like this can still work with a modern Samba server. We're using Samba 4.16 on a FreeBSD file server, and setting server min protocol to LANman 1 enables the SMB version 1 protocol for these older clients. With the testbed PC set up and ready to go, we then turned our attention to the dev side. We decided to work with the latest version of Impulse 7.1, as it is supposed to be the most stable. Opening up the source code zip file, there are dozens of PAS files, which is the Pascal source code. Pascal programs use a hierarchical structure with a main program and supporting procedures, with separate modules called units that can be used across other units and in the main program file. In the case of Impulse, imp.pas is the main program file, and the rest of the PAS files are the supporting units. Back in the 90s, if you were developing Pascal applications like bulletin board systems, you'd most likely be using either Turbo Pascal or Borland Pascal, both from Borland International. Turbo Pascal was incredibly popular with hobbyists, students, and indie developers thanks to its price point at just $100. Borland Pascal, on the other hand, was the professional-grade version, costing anywhere from $300 to $500 or more. It included advanced features, additional libraries, and professional development tools that corporate developers needed. Our first hurdle was just seeing if we could get the code to compile. The source code had a few batch scripts, but none of them seemed to be related to compiling, and there weren't any helpful pointers in the README files. We were in over our heads, and were fortunate to get help from renowned BBS scene expert Jack Flash, who advised us to start with Borland Pascal. Several floppy disks later, we quickly had Borland Pascal installed and attempted to compile imp.pas. But we immediately run into our first problem. checkpat.tpu is missing. This was a compiled unit file dependency that the code used but wasn't included with the source code. Jack Flash was actually closely collaborating with Brandon Sneed back in the late 90s and volunteered to test and provide some menu art during the brief Nexus 2 development phase. So, not surprisingly, we found the checkpat.tpu file that he had previously posted online. With that in place, we can now go through the build and compile steps, but we hit another snag. Mail 9 is missing. Exiting out, it seems we've hit some sort of limitation when trying to compile from the network share, as we can't even do a directory listing now. After rebooting and copying the files over to the local drive, we try once more. And this time, we're successful. We now have the imp.exe and imp.ovr files. The OVR file is an overlay file that contains code segments loaded into memory only when needed, which allows DOS programs to work around the 640 kilobyte conventional memory limit by dynamically swapping code in and out during execution. But now that we know we can compile the code in a real DOS environment, we wanted to automate this process as much as possible before continuing. So we created a build script that could be launched from Linux, which sets up a DOSBox environment and compiles the source code using Borland Pascal's command line compiler. When the script completes, it gives us the newly built imp.exe and overlay files. With the build script working, we then wanted modern version control so we could track changes while we tinkered with the code. So naturally, we turned to Git. We're using GitLab Community Edition as this allows us to self-host our own instance in a virtual machine. With the GitLab install done, we then created a repo and loaded the Impulse 7.1 source code. And then created a YAML script that uses Docker to automate the build process. This allows us to make changes to the Pascal code, push the changes to GitLab, which then kicks off the build pipeline defined by the YAML script. This creates what's called a CI/CD pipeline, which stands for Continuous Integration and Continuous Deployment. Think of it as an automated assembly line for code. Every time we make changes to the Pascal source, the pipeline automatically runs our build script without any manual intervention. When the build's complete, we're even notified in our serial port Slack. With our development pipeline now operating, we could get to the fun part, seeing if it actually worked. Just running imp.exe on our testbed results in a message that status.dat is missing. But we found the file in the pre-compiled release version, so we copied that over, and now we get a runtime error of 100. Looking at the docs applied with the release version, we see that we can use -d to set the home directory of Impulse, so we tried that. We get a little further this time, but now a runtime error of 3. Starting over, we took our compiled exe and overlay file and unzipped the release version into the same directory. Now running imp-d, we get a message about setting the date and time. We realized at this point this might be a dreaded Y2K issue, as changing the system date to 1999 allowed Impulse to actually start. Before we proceed any further, we have our first development task, fixing this Y2K bug. After some poking around, we found an issue in the common.pas file. In the original code, any year from 1985 and onwards is valid, but only up to 1999. We instead just implemented a simple fix where we assume 2-digit years of less than 80 indicate years of 2000 to 2079, and anything 80 or above is 1980 to 1999. So we've done it properly by kicking the can down the road. Now a developer in the future can come along in the year 2080 and curse at us.
What? Those jerks!
We've set our date and time back to present day, and then tried our new build. And wow, it works! This confirms our Y2K fix was a success, and that our build pipeline operates as intended. After logging in locally and poking around, obviously the first thing we had to do was try out a dial-in call from a modem. After configuring the modem settings in Impulse, we gave it a shot.
Holy
We did it! Mark was able to connect to Impulse over a modem, cementing our success in getting Impulse working with our automated build pipeline, ushering this old underground BBS software back into the modern age. We started out by asking if we could make working with older programs like BBSes easier. And the answer is a resounding yes. We learned a great deal about how to set up environments like this, which will undoubtedly help us out in future projects. And our Git repository is public, so feel free to check it out at gitlab.serialport.org if you want to keep up with any future changes or additions. We owe Jack Flash of Demonic a big thank you for his help along the way, as well as Brandon Sneed for all of the background on how Impulse was developed. Working on this project was the closest we've come to recreating the thrill of connecting to a new BBS for the first time. BBS videos may not be the most popular on YouTube, but like Brandon, they represent our favorite time in computing, so we'll continue to try to preserve that era as best we can. Thanks for watching the Serial Port, and we'll see you next time.
Do you recall like what it was like kind of the day-to-day as a developer when you were working on Impulse? Like how would you track your changes and stuff like that?
You didn't. But yeah, there's definitely bugs in it. You hit this button, this thing's supposed to happen, and it doesn't work. Like, but then I don't doubt that there's crashes, but I think most of the bugs are more along those lines of the former, where it doesn't do what you expect it to do more than anything else. You could go get a master's degree in computer science and never have to write a device driver or talk directly to hardware or anything like that. You would have to go into the hardware engineering program to learn how to write that kind of software. Ironically, it's kind of wild, and I think that leads to, I don't know, some of the things that we see now, right? Where it's like, oh yeah, you open up your browser and it's using like 3 gigabytes of RAM. It's like, well, because they didn't have to go through those times where RAM wasn't abundant, so they don't think about stuff like that in the same way,